So welcome. This is two-dimensional motion. It's really one-dimensional motion twice. Sometimes it's one-dimensional motion dressed up as two-dimensional motion, but we'll see it. So let me put an alarm on for something like 50 minutes, and we'll break it up into 2 bits. So here we have two-dimension motion. We're going to use component equations for two-dimensional motion. That works really nicely. We're going to do projectile motion, which is basically two-dimensional motion in which one of the dimensions is vertically in a gravity field. We're going to do vector equations. We cannot always use them, but sometimes we can. And then we're going to do this final thing, which is relative motion. So, same old equations. Exactly what we learned before. Vf equals Vi plus A delta T. Delta x equals a half Vi plus Vf delta T. Delta x equals Vi delta T plus a half A delta T squared. And Vf squared equals Vi squared plus 2A delta x. Actually, that should be delta x there. And if it's in the x direction, we call it the x direction information. If it's in the y direction, we call it the y direction information. X meaning, for the most part, horizontal, and y meaning vertical, but it could be on a table. It could be down a slope and perpendicular to a slope. It's as long as they're at 90 degrees to each other. I don't bother renaming things, so I'm not going to call that delta y because delta x means displacement to me. If it's delta x and it's in the y-axis column, it's in the y direction. But other people call it delta y, and I'm not going to write out a whole new set of equations for something like that. So your choice. You can call it delta y, you can call it delta x, but you've got to know just what it means. Particle starts from the origin. Initial velocity of plus 4 meters per second and a constant acceleration of plus 2 meters per second squared along the x-axis. So they're both positive. Plus 4 meters per second. Plus 2 meters per second squared. It has initial velocity of minus 3 meters per second and initial acceleration of plus 6 meters per second squared. So here it is at time t equals 0. And I want to know t equals 5 seconds. I'm guessing. I have no idea what it's going to be, but I'm guessing. I'm actually not guessing that much, but I'm guessing a little bit. So there's my visualization. Can you see how you might not be able to see because maybe you don't think the same way I do, but for me the diagram explains what the words mean. Can you see how it's very easy for me to think about this thing as speeding up in the x direction? It's traveling to the right because it's a positive velocity, and it's speeding up because the acceleration is also to the right. Now can you see how it's traveling downwards, but it's slowing down? Eventually it's going to stop, and then it will start traveling upwards with an increasing velocity. So if I think about this horizontal axis, there's my position at time t equals 0, and then it goes to there, and then it goes to there, and then it goes to there, and then it goes to there. Can you see how it's speeding up? And then if this is my y, it's going there, but it's slowing down, it's slowing down, it's stopped, it's speeding up. And it goes up like that. So the shadow goes down and then goes up. Imagine a light shining from the right-hand side into the object. The object's doing some weird shape, and this is the shadow of the object on a vertical wall, a y-axis wall. And on this one, it just takes off in that direction. And if I put these guys together, what I see is, oh, okay, so we're down here, and then we're down there, and then we're down there, and I get a shape that looks something like this. Whoosh, like that. And I guessed, I said I'm somewhere like here. I'm guessing, you know, somewhere like that. You don't have to be able to do that, but it makes life easier if you can. It really, you know, no engineers don't get paid because they can put numbers into equations. Kind of anybody can do that. You've got to bring something else to the table, and what you bring is your visualization or your insight. And that's just practice. The approach is you only do one axis at a time. So it says, what is the XY position? And there's my X and there's my Y, so, okay. Find X pos using X info. Always use the axis of what you want to find out. I make a list. I go, well, let's look at my diagram. I have VI is equal to plus 4 meters per second. A is equal to plus 2 meters per second squared. My time interval, well, I started off at 0 and then it wants it when t equals 5, so that's 5 seconds, and I want to find my position. This is a one-dimensional problem. Delta x is equal to VI delta t plus 1/2 a delta t squared. So delta x is going to equal VI is plus 4 times 5 plus 1/2 times plus 2 times 5 squared. So delta x is equal to plus 20 added to plus 25. I think I'm right on that. Delta x is equal to plus 45 meters. That's my first bit. It's just a one-dimensional problem. So I had to be able to pick the dimension from all the information. But find y pos using y info. Make a list. VI is equal to minus 3 meters per second. A is equal to plus 6 meters per second squared. Delta t is equal to 5 seconds. Delta x is equal to, I don't know. Same equation. Delta x is equal to VI delta t plus 1/2 a delta t squared. Delta x is equal to minus 3 times 5 plus 1/2 times plus 6 times 5 squared. Delta x is going to equal minus 15 added to plus 75. Delta x is equal to plus 60 meters. So across here, 45 and 60. Boom, 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 boom. So 2 little bits that were one-dimensional. The trick with that was recognizing the fact that you can only use X information with X information and only use Y information with Y information. So what might this be an example of? If you want to make a guitar faceplate, you usually got a system where you have one gantry which moves in the X, and that rides on top of a slider that moves in the Y. You have two motors, one driving the X and one driving the Y. And so basically you got to give it instructions about, travel at this velocity with this acceleration in the Y and travel with this velocity and this acceleration in the X to get the shape that you want. It's that kind of thing. These days it's done digitally, where I'm sure it has a whole bunch of encoded addresses, but back in the day, that's kind of how you do it. The trick with this is that you don't know any information unless I tell you it. But with projectiles, you know a lot of information because I told you it was a projectile. So projectile motion is a projectile. By definition, the name means you're in free fall. So if I kick a football, it's a projectile. I'm assuming air resistance can be ignored. If I can't ignore air resistance, I shouldn't call it a projectile. A rocket is not a projectile because it has a motor on the back which is accelerating it, it's applying a force to it. But a bullet would be a projectile once it leaves the gun. A cannonball is a projectile once it leaves the cannon. If I run and dive off the edge of a building, I'm a projectile once I leave the building. If I kick a football, the football is projectile once it leaves my foot. Because once it's left my foot, the only thing acting on it is the acceleration due to gravity. So we can say the effective air resistance can be assumed to be ignored, and the acceleration is not graded for heavy objects. So here's a little bit of a wrinkle, which is that you might be tempted to think that small object, small weight, small force, small acceleration, and big object, big weight, big force, big acceleration. That's not true. And that's one of those things where the thing about physics is when you just accept things on face value, it seems really straightforward, but if we change anything, you're kind of mystified. I understood what you said, but now you're asking me something that's not what you said, because there's no fundamental understanding. And the only way to get that fundamental understanding is to try and think deeper. But the problem when you think deeper is, at first you get into a whole bunch of confusion. Like that. Big force means big acceleration. Big weight should mean big acceleration. Now he's telling me the acceleration is the same, whether it's a big weight or a small weight. Yes?
The only thing that should act on it would be, well, they say air resistance, but like surface area for air resistance?
No. Well,
if you have a sheet of metal.
It's kind of, but even without that, even if you take that away, the reason why you have a big weight is because you've got a big mass. And the big mass means big inertia. So it's one of these self-regulating things where when I have a little mass and a big mass, yeah, I get a little weight and a big weight, but I get a little bit of inertia and a big bit of inertia. So yeah, F equals ma, that's for sure. A is equal to F over m, which is the same as big F over big M is the same as little f over little m. So because you're using the mass to create the weight, and the mass is also causing the inertia, the two effects cancel each other. It's kind of like cute in a way. You wouldn't predict it, but it works really well. And so that's part of that process of it's really worthwhile. You want to be a good engineer, really think about this stuff and try to visualize it, because you will, and it is frustrating, you will run into these things where now I don't understand, man, I understood and now I don't understand. And regard that as an opportunity to get very much stronger. That's like playing somebody who's a better ball player than you are. it'll bring the best out of you. If you never go out and compete with anybody, you won't get that next level. So to some extent, you're competing with yourself, but you're kind of like going, let's think about this a bit deeper. And then it gets easier. Then you start putting all these jigsaw puzzle pieces together. You're not remembering them. They all fit. Then you go, oh, of course that goes like that, because the underpinning is all there. So don't think of, confusion on exam day as, something to be avoided. Confusion before exam day is to some extent something to be welcomed, because it means that you're digging a bit deeper, and your kind of thinking's telling you what you need to work on. Projectile follows a two-dimensional path, which is a parabola. That works out from the math. The acceleration in the y direction is minus 10 meters per second squared. Some people say minus 9.8. The acceleration in the x-axis is 0. Now that's interesting. If the force is downwards, there's no force sideways. You are traveling sideways because of inertia. Yeah, in the cannon you might have been kicked out sideways, but we can't talk about inside the cannon. That's not a projectile. It's a projectile when it's out of the cannon before it hits the ground or the water. So there's no sideways force. There's just inertia that's making you go sideways. And the acceleration in the x-axis is 0 because you've left the firing device. We must consider a projectile's vertical component of motion independent from its horizontal component. Projectile travels sideways for as long as it is above the ground. It's not like Tom and Jerry where you kind of go like that and then you realize, oh, I better land. It's like you just steadily move sideways, but your vertical has a limited amount of time, so when you put the two guys together, oh, that's when I hit the ground. So your time tends to be controlled by your vertical axis. Projectile travels sideways for as long as it's above the ground. The vertical axis governs the duration of the journey. Notice this diagram. I have my velocity, which is positive, getting less to 0. That's because there's a acceleration acting on it. And then the velocity increases in the other direction. But my sideways velocity is just steadily constant because there's no acceleration sideways, because there's no force sideways with the projectile. Ball is kicked 30 degrees from level ground at an angle of elevation of 30 degrees above the horizontal. That's specific language. That's like lawyers' language. Lawyers always tend to use the same. I remember when I first came to the States, I was in a car accident. I was a passenger, but I was in a car accident, and we were on the pavement, and the first aid people came around, the paramedics came around to see if we were okay. And the guy in the other car said, "I have contusions." And I thought, whoa, that's like... In Britain, they'd say, "I've hurt my leg." He goes, "I've got contusions." And, it's kind of like that language. It's medical language. It's specific. It's, And I suspected he was something to do with medicine. He might not have been. I don't know, but it's not part of my vocabulary. But part of that game is talking like engineers and understanding what the words mean. And so when you see something like that, an angle of elevation of 30 degrees above the horizontal, it means it's an angle of elevation and it's 30 degrees above the horizontal. This will be below the horizontal. So there's some methodology to it. So with what angle would it approach the ground? So you want to commit? I didn't give out the clickers today. I'll do it bit by bit. So put down A, B, or C, just in your mind, what you think it is. And I'm going to tell you that the right answer is B. And can anybody justify that for me? Why is it B? Why is it exactly 30 degrees, 30 degrees below the horizontal?
It's traveling as a parabola.
Yeah, it's exactly a parabola. From a physics point of view, that's a math answer. From a physics point of view, what is it that would not cause it to be 30 degrees that we have missing from air resistance? With air resistance, this thing would lose speed and it would fade. And if you've ever been to the beach and played with a beach ball, tried to play soccer with a beach ball, you know, the thing dies. It kind of like you kick it and it goes and it's falling vertically downwards. It's great for headers. It's lousy for scoring shots. But when I was a kid, the soccer ball was really heavy. It was heavy leather, and if it got wet, it would rattle your foot when you hit it. But if you got it going, it kept going. It's like air resistance had very little effect on it. So that was conceptual, wasn't it? Cannonball is fired with a muzzle speed. That's the speed that it comes out of the cannon with. Muzzle speed of 4 meters per second horizontally off a cliff. What is the acceleration of the cannonball? What is the acceleration in the horizontal direction? Can you commit to that, please? Write it down or mentally make a note of it. But commit, and then you know if you got it right or you got it wrong. If you don't commit, you never know whether you knew it. And the answer is going to be C. Anybody explain that for me? Yes?
You told us that there's no acceleration in the horizontal direction, only in the y direction.
Yes. Once you've left, very good. Once you've left the cannon, you are coasting because there's no force horizontally. If there was air resistance, there would be a backwards force horizontally. And certainly you've left all those gases that are pushing you down the barrel of the cannon. So no force, no acceleration. Good. Again, conceptual. Cannonball is fired with a muzzle speed of 4 meters per second horizontally off a cliff. It takes 3 seconds for the cannonball to hit the sea. What is the final velocity in the horizontal direction? So, whoosh, I want to know that velocity. Think about it. And the correct answer is going to be plus 4 meters per second. Anybody want to justify that for me?
Acceleration is 0, it's going to stay the same.
Yeah, acceleration is the rate of change of velocity. If my horizontal acceleration is 0, I have no change in velocity. So it stays the same. Positive because it's going to the right. Good, very good. So 3 conceptual questions really. Got some complicated numbers in here, so this might not be conceptual. Cannonball is fired with a muzzle speed of 4 meters per second horizontally up a cliff. It takes 3 seconds for the cannonball to hit the sea. What is the range of the cannonball? So I got a new terminology. There's my range. The range is the horizontal displacement. That's typically what we call the range. You see it more in Physics 2. In Physics 2, there's kind of twice as much content. In terms of equations, there's twice as many equations as Physics 1 and all that. And I read this report which said that in general physics, there was more new vocabulary than there was when you learn a foreign language. And I couldn't believe that. My wife is an English-French major, and she was going, I'm not sure about that. And then she said, well, when you think about it, though, I mean, what you talk about are, you know, going for a meal, or meeting people, or, you know, in French 1 and 2, you know. I failed French, so I'm not a good example. But I don't recall talking about anything apart from having dinner, booking a hotel, driving through the countryside. That's what we always, maybe that's why I failed. Maybe we should have done all the other stuff like trying to get a job. So I can believe it, especially in Physics 2. There's an awful lot of vocabulary. So we get a new word, so we kind of like, rather than shutting it out and saying, I hope that word never comes up, you say, okay, we've got a new word, new terminology. Okay, so I want to find the range. I need to find R using, is it vertical or horizontal?
Horizontal.
It's horizontal, so using hor info. And I'm looking at my diagram and going, well, VI equaled 4 meters per second, positive, I suppose. And A horizontally is 0 meters per second squared. I have a little alarm bell there because it's easy to put down 10 because you're just on autopilot. So for acceleration, I've always got a little bit of a double check. Let's have a look. I want to find my delta x because my delta x is equal to r, which equals to, I don't know. Need one more thing. Oh, it gives me time, doesn't it? Delta t is equal to 3 seconds. I think I've got everything I need. So I go along and say delta x is equal to vi delta t plus 1/2 a delta t squared. That's the third time I've used that equation. It tends to be the one that mathematically is a bit more involved. But they're not all used equally. It's not that, and I'm not saying by that forget about the other three. You don't need them. You do. But don't be surprised that you tend to practice a couple of them more than the others. But you still need to know them all. So delta x is equal to, then just put our numbers in, plus 4 times 3 plus 1/2 times 0 times 3 squared. So delta x is equal to plus 12 added to 0. So delta x is equal to plus 12 meters. And to be nice, I'd say r is equal to 12 meters. Range is not a vector, it's a scalar, it's a magnitude if you like, so you don't really need a sign on. If you get me either one of those answers, I would be perfectly happy with them. I'm just being a bit pedantic by saying, oh yeah, it's 12 meters. Again, a one-dimensional problem, but this time dressed up as much more as a two-dimensional problem. Some people would just turn around and say, oh, well, yeah, I mean, distance equals velocity times time in the absence of acceleration. There's no acceleration, so I just go, well, 3 times 4 is 12. I can do it in 2 lines. And you can. And if you put down, there is no acceleration horizontally, so I'd say fine. But you're learning a special case there. You're learning what's different when acceleration equals 0. And to me, 0 acceleration is like a number. It's like it's not 1, it's 0. So I don't like special cases if I can avoid them. So there's my general equation. I put in the actual value for today, and I get my answer. So I'm kind of like simplifying things in my own mind. My approach is the same. It's kind of interesting. The Romans had no name for 0. If you don't have any troops, you got no troops. What are you talking about troops for? It's like, how many troops do you have? Why are you asking me? I've not got any. So they only had numbers for what you had. And it was after basically the sacking of Constantinople, actually, when Europe was coming out of the Dark Ages. They basically looted the library in Constantinople, modern-day Istanbul. And they got all these books. And the books had their roots going back earlier than Greece, before that. Came out of Mesopotamia, the root of the language, the root of the we have 360 degrees because of basically Babylonia. The root goes right back there. So this knowledge was to some extent been rediscovered, but they didn't know it anymore, so it was like new to them. And there was this word called 0, and they were going, what's 0? And I don't know. What's Latin for 0? We don't have Latin for 0. So what do? Well, write it down. they'll figure it out later. So they put 0. So 0 is an Arabic term which was injected into a Latin language because it was just taken from there. We didn't have the Europeans didn't have the concept of 0 as a number, whereas the Persians and the Middle East, they developed that idea. India developed that idea. Cannonball is fired with a muzzle speed of 4 meters per second horizontally off a cliff. If it takes 3 seconds for the cannonball to hit the sea, what is the height of the cliff? Not even a diagram now. I'm kind of like, I'm saying, hey, you guys can get on with this. There's my visualization. Find H using, what kind of information is it? Vert, isn't it? Make my list. VI is equal to, what is my vertical initial velocity? It's here. It's going to be 0 meters per second, isn't it? My A is, again, a little bit carefully, minus 10 meters per second squared. My delta X, I know it's in the y-axis. My displacement in the y-axis is going to be, that's what I want to find out. And my time is equal to 3 seconds. Yeah, same old, same old. So delta X is going to equal 0 plus minus 15 times 5, 75. Am I right?
What?
5, 15, 75, yeah.
It's be 45.
45. Oh, 3 threes are 9. Yeah, 3 threes are 9, sorry. And 5 nines are 45, yeah. Duh. Thank you. That's going to be minus 45 meters. Why is it negative? Is there something just wrong? Whenever you see a negative sign, your math's wrong. Is that right? So why is it negative?
Measuring from the cannon to the...
Yeah. There's the start, and here's the end. And that's downwards. That's displacement. Displacement's a vector. So I would accept that if you turned around and said H is equal to 45 meters. So much the better. But either one of those would be, I know you know what you're doing. Cool. Yep. Cannonball is fired with a muzzle speed of 15 meters per second horizontally up a cliff. It takes 3 seconds for the cannonball to hit the sea. What is the speed of the ball as it hits the water? Yes.
Just a quick question on the last one.
Sorry.
It said that it came out of the muzzle at 4 meters per second.
Yeah.
So even though it's leaving the barrel, doesn't that count as an initial velocity or not?
So vertical. Fired horizontal. So they're at 90 degrees to each other. So it doesn't matter what my horizontal velocity is. All that counts is what's my vertical velocity. Yeah, cool. Good question. At least I've changed the number this time. It's getting a bit more interesting though. what is the speed of the ball as it hits the water? Speed is not directional. It's how fast you travel in, in any direction. So my speed is kind of like that. There's my speed. But I can only work horizontally and vertically, so I got to basically, I like to change my color of my pen so you can see kind of like when I'm thinking and when I'm not thinking. So I have, that's going to be my Vx final. I just made that up, it's shorthand. It's my final velocity in the x direction. And then this is Vy final. So all I can say is my speed squared is equal to, think about it in terms of triangles, speed,
Vx final squared, Vy final plus Vy final squared.
yeah, Vx final squared plus Vy final squared. Whose theorem did we just use? Pythagoras. We recognized, oh look, these are at 90 degrees to each other, which is kind of nice. It makes a nice rectangle, and half a rectangle is a triangle. It's a right triangle, so I can use Pythagoras. Okay, so my speed is equal to the square root of Vx final squared plus Vy final squared. All I have to do is figure out what those two things are. Find Vx final using. So what am I going to use for that? Vertical or horizontal information? Vx final. I'm going to use har. Inf. Make my list. Vi horizontally is plus 15 meters per second. A horizontal equals 0 meters per second squared. Delta t is equal to 3 seconds, and I want delta x. Man. Delta x is equal to Vi delta t plus 1/2 a delta t squared. So delta, whoa, what am I doing? I don't want delta x. Autopilot. Bad. Sorry about that. Vf equals, I don't know. Vf equals Vi plus a delta t. Vf is equal to plus 15 plus 0 times 3. Vf is equal to plus 15 meters per second. And you might have just been able to spot that and say, from concept, no change in acceleration horizontal equals 0, no change in horizontal velocity. Find Vy using vert. Inf. Vi equals 0 meters per second. A is equal to minus 10 meters per second squared. Delta t is equal to 3 seconds. I want V final equals. Notice out of that list of 4 things, one of them you want, one of them you know, 2 of them you had to get from the context. Nowhere up here does it say minus 10 meters per second squared, and nowhere up here does it say 0 meters per second. That's all from concept. from context. VF is equal to VI plus A delta T. VF is equal to 0 plus minus 10 times 3. VF is equal to minus 30 meters per second. I'm going to change colour of my pen so you can see my next little bit of thinking, which is going to go in here. SP is equal to the square root of 15 squared plus minus 30 squared. SP is equal to, did I bring one? Yeah, I'm a physics person. 15 squared, enter 225, 900. 1125, I think. And I'm getting 33.54. So it's long. It's bringing together. So what's it testing? It's testing, do you know enough to work only in X when you want to find something with X, only in Y when you want to find something in Y? Can you visualize at the end and put those two components together to make the value of the final thing? So there's a little bit of fundamental understanding about components at the end. Yeah, that's what it is. It's a bit long though. Just check. Let me have a quick look at my time. Oh God, I've got time. Cannonball is fired on a level field with a muzzle speed of 40 meters per second at 30 degrees. Now remember, big diagram. Try not to make your angles 45 degrees. If I have a little angle and a big angle, it really helps me. And then this is 40 meters per second. You can visualize the journey. There's nothing wrong with that. But you're going to think in terms of what's happening on these two axes. What is its maximum height? Its maximum height is there, but again, I'm going to think in terms of H. I'm going to think in terms of that's what I want. Is that maximum height vertical information or horizontal information? It's vertical, isn't it? It's not saying where does the maximum height occur. It's saying what is the maximum height. Find H using vert inf. VI is equal to, can somebody say for me the expression involving 40 and 30 using trig for the value of VI? It's going to be 40 something 30. What's the something? It's going to be for VI, let's just, I'm talking about vertical information. I'm visualizing there's the VI I'm interested in because it's vertical information. So that would be 40 sine 30. Can you see it? Remember what we said. If you want something, and you're going to use something, and you're using the angle in between, it's the cosine of that angle. And if you want something, and you're using something, and you're using the complement of that angle, it's the sine of that. So it'd be the sine of 30, but the cosine of 60. Yeah. And that's practice. That's not smarts. That's just doing it and doing it and doing it and doing it. So, and it's going to keep coming up. So just keep working at that. Some people hate to leave it in this form. Some people love to leave it in this form. You know, it doesn't matter. There's nothing wrong with saying that this equals, check you're in degrees, 40 sine 30, and I'm getting 20 on that. There's nothing wrong with putting that down as 20 meters per second. There's nothing wrong with that. But you can leave it as 40 sine 30 and see if something cancels. But, you know, it's just a number. And then A vertically is minus 10 meters per second squared. And then, let's have a look. I want to find my delta x. There's two things left. There's delta t, and there's VF. I need one of those two to be able to answer this question. Yeah. VF is 0. You can recognize and say, well, if that's the end of my journey, and there's the start of my journey, I'm going slower and slower and slower until I stop. So VF is equal to 0 meters per second. And notice that's not written down anywhere. That's purely from context. So I go VF squared equals VI squared plus 2A delta x. 0 squared is equal to 20 squared plus 2 times minus 10 times delta x. So delta x is going to equal 20 squared over 20, which equals 20. Positive 20. And I can say from that, again, h is equal to 20 meters. That's really my answer. Whole bunch of 20s floating around there, which is bad teaching. I should use different numbers so we don't get 20s and 20s divided. So again, one-dimensional working, but in a two-dimensional context. More and more conceptual stuff coming in that you're just not taught about. You're just like, hey, you know. Cannonball is fired. 40 degrees. It's not quite 45. 25 meters per second. What's its range? Find using, what am I going to use, vertical or horizontal? Horizontal information. VI is equal to VI is equal to 25 cosine 40. 25 cosine 40. How? Yep. I'm visualizing my triangles. I had a lot of problem with components. And I kept thinking, because I kept getting the cosine and the sines, and sometimes I'd have it on top and sometimes on the bottom. And finally, I'd get half of them right and half of them wrong, and finally I realized I was drawing the wrong triangles. I was visualizing it wrong. Once I sorted that out, the trig was not the point. It was the visualization. 25 cosine 40. That's going to be 19.15. Horizontal A is equal to 0 meters per second squared. Delta X is equal to R, which equals to, I don't know. There's two more things. There's delta T and there's VF.
Yeah, negative 25.
So the VF is here. And you do know the VF. There's no question. The VF, don't copy this down, or if you do, leave space, because VF is going to equal just the same, 19.15 meters per second. Same direction, same speed. Problem. You look at those and you go, oh yeah, VF squared equals VI squared plus 2A delta X. So you go 19.15 squared equals 19.15 squared plus 2 times 0 times delta X. So the very thing I want is flushed away because I multiplied it by 0. So there's nothing wrong with what you wrote down, but it's not helping you at all. It's completely redundant. So it's not going to help us. So with a bit of experience, this is where experience comes in. It's like practice really helps. A really smart person will not necessarily do well unless they practice. It's like, you can be the best athlete in the world, but if you don't go out and hit that tennis ball, you'll just not do well, So you need practice, and this is one of the things about it. So we come along and we say, well, okay, delta T is what I need. And I say, well, what will go together with that? I'm going to say delta X is equal to VI delta T plus 1/2 A delta T squared. Not so bad because that A is going to go away. So delta X is equal to 19.15 times delta T plus 0. If only I knew that delta T. Man, if only I knew that delta T. You've used your X info, so you can't find delta T using X. If you could, you would have done. So now I'm thinking in the Y direction. And I make a list. I go, VI is equal to 25 sine 40. And that equals 16.07. Oh. Got to be careful here. A is equal to minus 10 meters per second squared. I got a choice to make about, I want to find, of course, delta T. There's two more things I could possibly know. One is V final, and the other one is my delta X, my displacement. We need one of them. Which one we're going to go with? No. let me, I'm a bit cautious about running out of time. Let me do this. Let me